All right, this is an extension of the solving absolute value equations. We're going to add a step in the front. So the first thing you got to do is get the absolute value bars by themselves. Okay, so either by dividing a number that's outside the value bars or adding a number, basically doing the opposite to the number that's outside the absolute value bars. And you'll see in our examples here. And then you do what we do before. So you make two equations, one that's equal to the positive number and one that's equal to the negative number. Okay? And then you solve like normal, which is reverse PEMDAS. Take care of your adding and subtracting first, then your multiplying, dividing, and then so on. Okay? So here's our first example. You can see we have 2, and then this is multiply. It's multiplying by the absolute value of 3x minus 6 equals 18. If you do not see, and I'm going to put a little dot here, if you don't see any symbol or like a sign, like a minus, a plus, anything, it's always multiply. Okay, so we have 2 times all that inside the bars. Well, before we can separate and make 2 equations, we need to get the absolute value bars by themselves. So we got to get rid of that 2. So in order to do that, we're going to do the opposite of multiplication, which is divide. So we're going to divide the entire side by 2, and we're going to divide that side by 2. Whatever we do to one side, we do to the other. And it enables us to cancel that out. And then we have absolute value of 3x minus 6 equals 18 divided by 2, which is 9. Okay, now we have our absolute value bars on their own. So all of that could equal negative 9, or all of that could equal 9 and negative 9. So this is where we split up our equations and make 2. So 3x minus 6 could equal 9, and 3x minus 6 could equal negative 9. And then we solve like normal. Okay, we have to get x by itself. So I'm going to add 6 to both sides. So I have 3x equals 9 plus 6 is 15. And I'm going to divide by 3. Cancels out. I get x equals 5. So that's done. And over here, I'm going to do the exact same thing. I'm going to add 6. Both sides. Cancels. So you got 3x equals. This is the only difference here. Negative 9 plus 6 is negative 3. Then I divide by 3, which is x equals negative 1. So you do the exact same solving steps. Your numbers are just going to turn out differently. So that is our first example. When you have a multiplying out in front, you just divide. Our second example here is we have 4 plus absolute value of 2x plus 8 equals 24. So this is the case where we see a sign here. We know it's plus, so we know that we're going to either add or subtract to get rid of that 4. Okay? In this case, we're going to subtract because the 4 is positive. So we're going to subtract 4 to both sides. Cancels out there, and so we're left with 2x plus 8 equals 24 minus 4 is 20. So now I have my absolute value bars on their own, and I can make 2 equations now. Okay, the 2x plus 8 could equal 20, or it can also equal negative 20. Okay, remember, anything inside absolute value bars could be positive or negative, because they're both going to turn into positive. So then I solve like normal. So I'm going to add. I'm going to subtract 8. My bad. Because it's adding, so I'm going to do the opposite. So I'm left with 2x equals 20 minus 8 is 12. And I'm going to divide by 2 to get x by itself. I got x equals 12 divided by 2 is 6. Okay, do the exact same steps. You're just going to get different numbers, okay, on this side. So subtract 8 from both sides, cancel. So I get 2x equals negative 20 minus 8 is negative 28. And I'm going to divide by 2. So I get x equals negative 28 divided by 2 is negative 14. Whoops. Whoa. What happened? There we go. What did I say? Negative 14. And I'm done. So the key thing here is to get the absolute value bars by themselves before you make two separate equations. If you have any questions, please let me know.